This, I hope I don't jinx myself. This ought to be a relatively simple lesson. That statement is predicated on the assumption, of course, that to this point you feel good, that you can move the midline and you can graph, your amplitude, how high to go, how low to go. So really all that changes today is we flip the graphs. So today is the 17th. And we are going to do reflected. And I should be more specific. Reflected vertically. Sine and cosine graphs. So, like I said, not a lot of, if this were the first time we'd ever graph trig functions, this is a big lesson, right? But you've been working and you understand where to put the midline. You understand where sine starts. You guys know, I think by now, that sine starts on the midline and works its way up. Cosine starts above and works its way back down. So you get all that. So today we're going to graph things like this. And I'll start us without any other modifications. We'll do one or two without any modifications, but I mean, it's got a negative, but as far as like amplitude or midline modifications, let's just start plain and simple. So the way we do this, and if you want more of that trig graph paper, I probably have some, but honestly, you don't need it. If you're just going to make a sketch of a graph, you're just going to start with your x-axis, or in this case, your theta axis, independent variable. And I don't need a bunch of periods. So like you don't need to go super far. But what we do want to do is tally off enough stuff. We'll start with the quadrantal angles. And this is just you going by hand, because I haven't asked you to do this yet. We've always had the little graphs provided on the paper for us. So in this case, we're just starting from scratch. So a really slick way to do this is to head all the way over and just go all the way to 2 pi. And just basically give yourself one full period like this. And then what we'll do is we'll subdivide from that point. It's a nice way to kind of keep things symmetric. So go to about the halfway point, and what's that going to be? Just pi, right? And then let's go and divvy again. What's halfway here? Pi over 2. And then we can do 3 pi over 2. And then we can mark some more points, but you don't have to necessarily label them, because like anyone who knows what's going on at all knows that those are pi over 4, 3 pi over 4, etc. So if this were a normal sign, if it just said y equals the sine of theta, then I'm going to do something here that I don't necessarily need you to do. I'm just going to show you where you should be at in your learning right now. So if this were a regular non-modified graph, you would go start at 0, at pi over 2, sine is 1, at pi, sine is 0, 3 pi over 2, sine's -1, and we're back. Like that's what one standard unmodified period of the sine function looks like, right? So what we're going to do is we're going to modify, and we're going to go the other direction. So what happens when you take a trig function and you multiply it by a negative is all of the verticals are just switched. They swap. So whereas sine, if you think about it, when you go to pi over 2, sine would normally climb up to 1, right? We're just going to reflect that. We're going to take it times the negative, and all the points are going to do exactly the opposite of what they otherwise would have. So at pi over 2, we're actually going to be at -1. That's just a simple vertical reflection. And then, of course, at pi, we're, as we would expect, back to 0. And then at 3 pi over 2, we're back up to 1, or up to 1, I should say. And then at 2 pi, we're, of course, back to 0. The points at which the graph touches the midline, those don't change, because negative multiplication doesn't affect the number 0. So the midline points stay the same, but the upsy downsies are just flip-flopped. So that's what one reflected period of the sine curve looks like. And then you would grab a pencil and start trying to connect. And you don't need, not for my benefit right now, you don't need any more of the between points at this point. So your curves should look something, I could do better, but you get the idea. Okay, And the same is going to be true if we modify a cosine curve with a reflection, is all of the normal things that we see are just going to be backwards. So what normally would be up one is going to be down one, and so on and so forth. So let's do a quick reflected cosine curve, and then we'll get to the ones with modifications. So let's quick take a look at y equals the negative of the cosine of theta. So same as before, sketch yourself a theta axis, sketch yourself a y axis. And until we start dealing with more periods to the left, you can put your y-axis pretty far, force it over to the left, because really all we want is just one nice big workspace for one period from 0 to 2 pi. So same as before, I'm going to head pretty far out here and put a 2 pi. I'm going to slicey dicey it right down the middle. And then I'm going to slicey dicey each of those right down the middle. And then, of course, put your little subdivisions, which if you have a reason to want to do those specific points, you're welcome to look at pi over 4 and 3 pi over 4. But really all I'm trying to accomplish today is those big 5 angles, the start, top, side, bottom, end. That's what we're going for. And because we're unmodified, I know that my amplitude is 1. So my high is 1 and my low is -1, and we're ready to start. Where does cosine start? At 1. But since we're reflecting the graph, where will cosine start? Correct. So cosine in this case actually starts down low. And when we get to pi over 2, cosine will be 0. When we get to pi, and normally it would be -1, right? But again, we're just reflecting. We're just taking everything that we're hopefully getting pretty good at by now and just doing it upside down. And so this is one reflected period of the cosine curve. And again, you would just grab your pencil and try to make it look curvy. Whoa, that one got hit with the ugly stick. Oh, I was doing okay, good. And look at that. It's like someone schwacked it with something. All right, so you ready to do the modifications? Piece of cake. By the way, one little trick, and I'll show you this more here in a minute. It doesn't really relate. It's not as applicable to a simple graph like this. But one thing that I'm going to encourage you to start doing is sketching 3 lines on every problem. The midline, the max line, and the midline. Or not the mid, but the bottom line, excuse me. So if you sketch those, you can see how off kilter I was there. If you sketch those lines, if those of you that do music, like how you have your clef or whatever you call that thing, it really helps to keep the graph locked in between based on the amplitude. So as we start moving our graphs up and down here in the next few minutes, I'm going to redraw a midline, I'm going to redraw a max line, and redraw a minimum line. And then it's a good guide for us as we ping our points. So can we what? Oh yeah, have a ruler. They're on that red thing. You want to hand them out? Go ahead, you're ruler man. That's a good idea. That idea rules.
That was funny.
Bryn doesn't want one because she can draw straight lines perfectly with just her. Is that Josie? Is Josie the straight line?
I thought you couldn't draw.
She's the straight line warrior.
Right, freak.
I literally was like, what? And you didn't say anything.
What is you want to do? No. How about I still think about it? Good man.
Oops. All right, so if we'll do a couple, I hope that I don't pile on here. I've gotten the sense from the working with you guys so far that this you're not going to struggle with a lot. Like you guys pick things up pretty quick. So we have triple modifications on this. So if you ever were in a test situation where someone said, name all the transformations, I would say, number 1, there's a vertical shift of up 4. Number 2, there's an amplitude adjustment of ×3, vertical stretch, we call that. And then number 3 is there's a vertical flip because of the negative. So all 3 of those are called transformations, and they all affect the graph in different ways. So we're going to start by drawing our, this might surprise you, but I'm going to draw my y-axis first. And the reason for that is because I want to focus not so much, and I'm going to draw something and I want you not to. I don't think it's necessarily appropriate in this case to draw my x-axis right down the center. Why not? Where is the bulk of the action going to take place? I mean, I use the term loosely. It's going to be way up above it, like 4. So if I do this, I'm really wasting a ton of space. So what I would do in a case like this is just think about the problem to come. And I might take my x-axis, honestly, and put it way down here like this. Because think about, like, where's the midline going to be? At 4. Good. At up 4. So, and then what's the amplitude? 3, right? -3, 3, the girth, the stretch is times 3. So the first thing I want to do is just be smart about, like, my y-axis. How far, what's the highest this graph will ever get? Nice job, 7. And what's the lowest it will ever get? 1. So let's start by drawing the midline, and then if you didn't understand the answers to those questions, then we'll take a look. So to color code, for you guys, I'll try to be consistent. I'll do red for my midline. So I'm going to go up to, nope, I'm on white. So I'm going to go up to, let's see, 1, 2, 3, 4, 5, 6, 7. This shouldn't be a half-hearted endeavor. Like, this part of the graph is where I'm thinking about setting the stage for what I want it to look like. So I'm going to go up to 4 because that's what my vertical adjustment says to do. And I'm going to draw a horizontal 1, 2, 3, 4 midline right here at 4. This is how we used to rock it back in the day. And I remember, like, thinking this felt good. So I think it'll feel good to you. But to give the graph even more structure, I'm going to go ahead and switch to about yellow, and I'm going to draw a top and a bottom. So remember, if the stretch is 3, then we know that the absolute highest the graph is ever going to get is 3 units above that. So I can draw a top cap up at 7. And where again is my bottom cap? At 1. So, and I don't know if you like those colors or not. I guess, is that crooked? Is this one crooked? Holy smokes. How did that, that one's got to go bye-bye. Delete. Ah, that was terrible. Let's try this again. Get good, noob. Oh, yeah. This is how I like to do it when I don't have a nice piece of graph paper. And what's beautiful is it's fully customizable. And now I've got the stage set. So all I need to do now is go down here to my x-axis or my theta axis and do the same drill as before. I'm going to go all the way out and label it 2 pi. I'm going to go midsies and put a regular pi. I'm going to go midsies on that and do a pi over 2, and then midsies of the higher half and get a 3 pi over 2. At this point in the problem now, the +4 is no longer of any consequence to us, okay? He served his purpose, and the amplitude also has almost served his purpose, the 3. What we need to consider now is who we're working with. So where does cosine start, on or away? Cosine starts away. So in this case, because cosine starts away, I'll do some purple dots here. Cosine is going to normally start at 1, but it gets reflected times -3. Cosine will start right there where the purple dot is. And now cosine is going to behave predictably. He always does. These functions don't change their behaviors. So at pi over 2, where will my cosine be? Back at 0. Right? I mean, yeah, back at the midline. Thank you for correcting that. It's like we think of it like the 0, but the midline is the key. Like, imagine trying to do this if you didn't have these lines to hold on to. But the structure of it is so cool because now I'm just graphing either on the capper lines or on the midline. And then, of course, there's some points that we probably should be filling in the tweener points. But for now, this is great. Where's pi? Remember, pi would normally be -1, but we reflect it times -3. So we go up 3 away from the midline, and that's going to be up here. And then, of course, you know that at 3 pi over 2, we're back to here. And then at 2 pi, we're back down to here. And that completes the cycle. Nothing to it, right? Having this structure is going to help us starting when we're getting close to the point where we can't avoid phase shifts and horizontal stretches anymore. So this is kind of the last of this. But the yellow and red line thing is going to be huge. It's going to help us a lot. And then as always, the hard part is, can I make this graph look decent? So kind of put a bump there and try to come up and keep it curving if you can. Whee! Hey, that side turned out good. This side got hit with the ugly stick, but that'll do. And the only thing missing that I would take points off of myself for, does anyone know what it would be? What would I complain about? I can't hear. What? Yeah, like I need to label my y-axis. So I don't know what I was thinking here, but I need to label these as 1, 2, 3, 4, 5, 6, 7. I should not have left that blank. So there. Do you want to do another one, or you think you got this? You good? Anyone? Anna, you good? Everybody good? Okay, so your assignment is on paper. I don't know if you knew this or not, but Bryn volunteered to hand these out. So thank you, Bryn, for doing the work. And then I'll leave the recording going. So if you guys want to go over any, then you're welcome to just ask. Okay. Doogie, ready?